بسم الله والصلاة والسلام على رسول الله. اللهم علمنا ما ينفعنا وانفعنا بما علمتنا إنك أنت العليم الحكيم. Today we're going to talk about information system hardware. What is a computer? A computer is a device that is electronic, can store data. It means consists of internal or external data storage, can store and follow a set of software instructions called a program. A program is a collection of instructions that can be executed by a computer to perform a specific task. Every system consists of inputs, processes, outputs, and feedback. The chart that you see is something called the system's model. It is a graphic representation of what a system really is. Inputs are the things that go into the system. These are the things that are needed to use, create, or maintain the system. A process is basically what is happening in the system. The outputs of the system is basically what comes out of the system. What is the result of using the system? Input device accepts data from outside the computer and converts it into an electronic form the computer can understand, such that device, keyboard, pointing device, scanner, touch screen, light pen, pen computer. Let's take each device alone.
This program comprises Unit 3, Input Devices. After completion of this unit, you will be able to describe the purpose of input devices, distinguish between different input devices, have knowledge about keyboard devices, have knowledge about speech recognition system, have knowledge about point and draw devices, have knowledge about date scanning devices. The input devices are used to enter data and instructions into the computer. Following are most widely used input devices. Keyboard device. Keyboard is a standard input device as readily available for us to feed the data. A keyboard is similar to a conventional typewriter with about 101 to 114 keys as shown below. A keyboard is divided into three major parts: function keys, numeric keys, alphabetic numeric keys, special keys, and screen navigation keys. Function keys. Function keys are 12 in number, labeled as F1 to F12. Function keys are programmable keys to perform a specific stored function. For example, F1 key is used for help option. Numeric keys. Numeric keypad is very important for entering numeric data. A numeric keypad is switched on and switched off by pressing numlock key. It is mostly situated on the right side of the keyboard. 0 to 9 and plus, minus, steric, slash, and enter keys are present in such a keyboard. A numeric keypad can also be used for arrow keys and page up and down tasks as mentioned on the keys. Alphabetic and numeric keypad. Alphanumeric keypad has alphabetic keys and numeric keys. This is a standard keypad and is similar to a typewriter. These keys are used to type the character data as well as numeric data. It has QWERTY keypad and is used to enter A to Z alphabets both in upper and lower case letters. In the above keypad, alphabetic keys 0 to 9 and numeric keys are present, and some symbols are printed and can be used by using the shift key. Special keys. These are some keys situated between alphanumeric and numeric keypad and surround the alphanumeric keypad as well. These are page up, page down, home, end, insert, delete, and Tab, Caps Lock, Shift, Control, Alt, Windows, Escape, etc. Screen navigation keys. These are called arrow keys situated between alphanumeric and numeric keypad. These are 4 arrow keys like left, right, up and down arrow keys. These are used to move cursor anywhere on the screen. Point and draw devices. Point and draw device is an input device which helps to rapidly point and select an icon to display on the screen. Some popular input devices are trackball, joystick, mouse, light pen, touch screen and digitizer. Trackball. Trackball. Trackball works just like a mouse. Trackball contains only one ball instead of different buttons like left or right, etc. Trackball uses this ball to move the cursor position from one location to the other. Trackball neither uses any such pad nor covers much space. Joystick. Joystick is a pointing device. Joystick is mostly used by children to play their games. It consists of a handle which can be used to move the object position left, right, up and down. Joystick can also be attached with a television set. It uses USB or special port supplied with sound card for connection. Mouse. Mouse is a pointing device. A user can move pointer very rapidly on the screen with the help of mouse. Mouse controls the movements of the cursor positions. There is variety of mouse available in the market. For example, wheel mouse, laser mouse, wireless mouse, etc. Wheel mouse. Wheel mouse contains left-right buttons and a wheel button at the middle. Wheel button is used to scroll the pages up and down very rapidly. Laser mouse. Laser mouse uses the laser beam for its movement. Laser mouse does not need any mouse pad. Laser mouse is automatically activated as it is attached with the computer. Light pen. Light pen is a pointing device which is used for making drawings. Light pen rapidly moves on the screen just like an ordinary pen, but it works with electricity. Light pen does not need any alphabetic keys. Touch screen. Touch screen enables the user to touch the data directly by using fingers within the display area. Touch screen is very simple and easy to use. Currently, it is also used in mobile phones. Digitizer. Digitizer is used to convert maps, pictures and drawings into a digital form to store in the computer system. A digitizer consists of a digitizing tablet and a stylus, pen. Digitizing tablet is a flat surface on which stylus or a pen is moved to draw shapes, pictures or maps, etc. Speech recognition device. Speech recognition allows a person to input data to the computer through speech. Speech recognition device converts the human voice into text. This device is especially helpful for disabled people. Speech recognition has the capability to first recognize words with the help of software or a device and then convert it into text or command. Types of speech recognition system. Single word speech recognition system. These systems recognize only single words like hello, yes, no, at one time. Continuous type of word speech recognition system. This type of speech recognition system recognizes more than one word or a complete sentence. For example, hello, how are you at one time. Uses of speech recognition system. Speech recognition systems are specially helpful for disabled people who cannot write. It helps people who feel comfortable in speech rather than writing. It facilitates a user in a situation where he or she is unable to edit or review a long text. It also helps the user who is quite busy and doesn't want to type the data due to shortage of time. Data scanning devices. Image scanner. An image scanner translates the printed documents into an electronic format and stores them into the computer. Important documents can be preserved in an electronic form by using image scanner for later use. Image scanners are further classified into the following two types. Flatbed scanner. Flatbed scanner is like a photocopier machine with a glass sheet. Flatbed scanners are also called desktop scanners. In a flatbed scanner, the paper is placed on a glass sheet and a light source is moved horizontally from one line to other line. The process is repeated until all the lines are completed. Handheld scanners. Handheld scanners work much like a flatbed scanner, but it works manually by the user itself. For scanning the documents or products, the scanner is dragged slowly with its light on. Handheld scanners are mostly used in shops to scan the price of products. Optical character recognition. Optical character recognition is also called optical character reader. Optical character readers use a software called OCR software. OCR software. The scanner first creates an image of the document and then the OCR software converts that image into ASCII text. Computer interprets the ASCII text as letters, numbers and special characters. OMR. Optical Mark Reader. Optical Mark Reader has the capability to recognize the pre-mentioned marks either of a pen or a pencil. Optical Mark Reader is specifically helpful for making objective type questions. The student marked the answer sheet by filling or darkening a circle, oval-shaped or square. This printed answer sheet is fed into the computer and the grading is done by using Optical Mark Reader. BCR. Barcode Reader. It is normally used in shops, grocery stores, etc. This device contains the photoelectric cells that read barcodes consisting of lines having different thickness. Barcode reader helps shopkeepers to analyze the price of an item immediately. MICR. Magnetic Ink Character Recognition. MICR is used to read the magnetically encoded characters. MICR is a system that provides a full alphanumeric recognition of printed or handwritten characters by simply scanning the form. A user scans the data through a scanner, which is recognized by an engine of the OCR system. The MICR converts the images into machine-readable characters. Electronic Card Reader (ECR). Electronic card reader is used to scan e-cards, smart cards like Visa card, bank credit cards, etc. An electronic card reader reads the memory card of the ATM or debit card or Visa card, etc. The memory card is in the form of a black strip which is wiped through an electronic card reader machine. Vision Input System. Vision Input System is one of the latest input devices that recognize the vision image which appears in the range of its lens. These are specially used to design industrial robots.
The role of output device is converting data from an electronic form inside the computer to a form that can be used outside the computer, such that device, a monitor device, printer, plotter. A monitor device is a device that produces on-screen text, graphics, and images, while printer is an instrument that produces on paper text and graphics and images. The plotter is an instrument that produces on paper high quality graphic outputs. The next video is going to discuss each device in details.
We will learn about output devices. This is an important lesson of your coursebook. This program comprises Unit 4, Output Devices. After going through this unit, you will be able to have knowledge about monitor and its types, have knowledge about printer and types of printers, have knowledge about plotter and types of plotter, explain special function terminals, have knowledge about voice response system. Monitor. Monitor is a standard output device which provides visual output from a computer. The first device monitor was used to view output generated by a computer on screen. A monitor is just like a TV screen. Monitors are of different types with different resolutions, sizes, and characteristics. Types of monitors. Following are the different types of monitors. Number 1, CRT, cathode ray tube monitor. Number 2, LCD, liquid crystal diode monitor. Number 3, LED, light emitted diode monitor. CRT monitor. Cathode ray tube CRT technology is an embedded vacuum tube technology, which is evolutionary in the field of monitors. These monitors are low cost, reliable, and available in different colors, etc. However, they consume much electricity and are heavy in weight. LCD monitor. A liquid crystal display monitor uses liquid crystals which were first discovered in 1888 by an Austrian botanist, Friedrich Rienster. These types of monitors are very slim and lightweight. The LCDs are rapidly replacing CRT monitors. LCD monitors are used in notebooks, small computers, pagers, phones, and other devices. LED monitor. LED or light emitting diode is an enhanced version of LCD with the fluorescent lamps having LED backlight. It uses a semiconductor diode instead of filament. LED is normally used in many devices such as cell phones, computers, monitors, flashlights, and movement sensors, etc. Graphic adapters. A video graphic is a device that performs graphic processing. It is also called graphic card, display adapter, video card, etc. It describes the resolution, refresh rate, and number of colors to be displayed on the monitor. Currently, the graphics circuit is built into the chipset. Size. The monitor size refers to the distance in inches from one corner to the other of the viewable area. A CRT monitor size actually measures the distance of the entire front of the monitor. The size of monitor screen is measured in inches. The commonly used monitor sizes are 14 inches, 15 inches, 17 inches, 19 inches, and 21 inches. Resolution. Resolution defines the number of horizontal and vertical pixels on the monitor. The pixels are the smallest component of a digital image and are combined to form a comprehensive picture. More pixels make better picture quality. Monitor resolution is measured in width by height, like 640 into 480 resolution means that the width of the screen is 640 pixels and 480 is its height. Printer. Normally, a user displays its output on the screen, but sometimes a user also needs to take the output in the form of a paper, which is possible with the help of a printer. Generally, a printer may be black and white, but color printers are also available. Printers are different in types. For example, dot matrix printer. Dot matrix printers are the character printers, which print one character at a time. It uses pin strikes on ribbon to form characters against paper. The speed of printing of dot matrix printer ranges from 30 to 550 characters per second. Number 1. Characteristics. Dot matrix is low-cost printer and consumes less energy. Number 2. Limitations. Dot matrix printers create noise during printing process. They print the text with low resolution. The font facility is limited and graphics quality is also not high. Inkjet printer. Inkjet printers are the character printers used to print all kinds of graphics. Inkjet printers print one character at a time and uses ink bottles in different color combinations. Inkjet printers use 4 ink cartridges. Graphic quality or text quality depends on the strength of the ink cartridge. Inkjet printers can be attached with the help of USB cable normally. Number 1. Characteristics. Inkjet printers consume less energy. The printing quality is high. Number 2. Limitations. Printing cost is high because refilling bottles makes the cost high. Drum printers. Drum printers are used to print an entire line at a time. It uses cylindrical drum as printing mechanism. Whenever a user wants to print a character, a desired character is rotated around to the hammer line. The hammer hits the paper and pushes it into the ribbon to print the character. Number 1. Characteristics. Drum printer is energy efficient. They consume less ink. Number 2. Limitations. The printing speed of drum printer is slow. The printing quality is low and they also produce noise during the printing. They cover a lot of space. Chain or band printers. Chain or band printer is also line printers that print one line at a time. Chain printers consists of a metallic chain or band and uses chain as its printing mechanism. A chain moves horizontally around a set of hammers. When a desired character appears in front of the selected printing position, the hammer hits the paper into the ribbon to print the character. Number 1. Characteristics. Chain or band printers are low cost. Number 2. Limitations. They consume much electricity and cover a lot of space. They also produce noise during the printing. Laser printer. Laser printers are called page printers that print one page at a time. The laser printers use toners to print the desired characters. They are also capable to print the high-quality graphic images with resolution ranges from 600 to 1200 dpi. To print a character printer, send laser beam to a rotating drum to form a character on drum and then transfer character image on paper. Number 1. Characteristics. Laser printers are speedier and noiseless. The printing quality is high. They can print on both sides of a paper. Number 2. Limitations. Laser printers are expensive. Plotters. Plotters are used to print architectural, engineering, and mechanical drawings on large sheets with high printing quality. Pen plotter is most commonly used plotter which consists of 6 or 8 color pen cartridges that move across the entire paper of the drawing. They are capable of printing complex technical drawings. Nowadays, these plotters are replaced by large capacity inkjet printers and LED toner-based printers. These are plotters but behave as raster plotters rather than pen plotters. Raster is a digital computer image which is the combination of small pixels. Special Function Terminal ATM's POS. ATM Automatic Teller Machine is used as an unattended device or a machine which is used in the banks for withdrawal of money outside the bank at any time. ATM provides a very easy and secure way for the money transactions. These sorts of machines use real-time operating system. ATM monitors are specifically used for the money transactions with the following key features. Characteristics. ATM provides instant cash withdrawal. They are used to inquire quick balance. The transfer of funds and money is easy to operate. The PIN number can be changed anytime. POS terminal. POS or point of scale terminal is used in place of cash registers on the shops. Currently, the POS terminals have replaced the manual systems of registering the record of sale and purchase. POS terminal immediately updates the sale and purchase records in the memory and also provides a printed receipt of the record. The POS system has the capability to record and track customer orders. They can also process credit and debit cards to their respective debit-credit card server systems over the network. These terminals are used in utility stores in Pakistan to maintain stock in machine and generate receipt of customer. Multimedia projector. Multimedia projector is used to display information from the computer onto a large screen. This device is specifically helpful in delivering lectures and presentations. There are further two prominent types of multimedia projectors. LCD multimedia projector. LCD projector is also called digital multimedia projector. LCD multimedia projector can adjust the brightness and contrast and produce sharp images. Some popular LCD multimedia projectors are ViewSonic, PJ862, Sony, etc. DLP Digital Light Processing Projector. DLP projectors are also called digital multimedia projectors. DLP projectors are portable, lighter in weight and smaller in size. These projectors produce best quality video images. They have the capability to connect easily to other digital devices like DVD players, CD players, etc. Voice response systems. Voice response systems enable computers to talk with a user. Voice response systems keep an audio response device that help produce audio output. In this way, these systems provide an easy communication to both user and computer. Voice response systems are of two types. 1. Voice reproduction system. Voice reproduction system uses a database of pre-recorded responses like words, phrases, or sentences which are spoken by a human being. It produces the output by selecting the particular words and phrases from the database. Applications of voice reproduction system. The most familiar example of using voice reproduction system is special ATM machine, which uses voice reproduction system to provide systematic or step-by-step guidance to its customers. It helps the customers to make a financial transaction. Another application is the automatic answering machine, which is mostly used in telephone inquiries like schedules of trains and aeroplanes, etc. Another interesting application is the children talking toys in which various exciting sounds are produced. Speech synthesizer. A speech synthesizer helps convert the text information into spoken words or sentences. A speech synthesizer program is helpful for disabled people who cannot easily read. Whenever a user feeds the data in the form of text information, the sequence of words is combined into phonemes. The phonemes are amplified and passed on to a speaker. Applications of speech synthesizer. Speech synthesizer is specially helpful for blind people who cannot read. In special education sector, study material or a book is presented to the blind person using a speech synthesizer. In this way, it becomes very easy for the blind person to get the updated knowledge or information. It is helpful for people who cannot speak with either vocal problems and those who cannot communicate effectively. For example, a person having a disability can simply type the information and the speech synthesizer converts his information into spoken words for him. Speech synthesizer is also helpful for the interpretation or translation into other languages. Speech synthesizer program converts an entered text into spoken words in any selected language.
There are two types of storage, primary and secondary storage. A primary storage is read and write storage, also called internal storage. It is a memory or RAM of the computer. Primary storage, which is temporary storage, is dependent on continuously electrical power. Any interruption of electrical power causes the content of the primary storage to be lost. Secondary storage stores data not currently being processed by the computer and represent permanent storage. Data is usually transferred to and from secondary storage. The example of secondary storage is hard disk, floppy, CD-ROM and DVDs. The next video will show us the primary and secondary storage in details.
Hello friends, I am Nilma. Welcome to my channel Omni Education. Today we are going to discuss the difference between primary and secondary memory. So let's get started. So guys, before understanding the primary and secondary memory in detail, we must understand why a computer needs memory. Do you know, a computer would never work without a memory. We know the basic computer system model where we give the input to the processor and it processes the input and gives the output. But there is one more element that is connected to the CPU, that is memory. In order to process the data, both the data to process and the instructions to process them need to be stored in the computer. All the computer data and instructions are stored in special locations of the computer, which is known as computer memory. Depending upon the type of storage, there are two basic types of memories that are primary memory and secondary memory, which we will discuss in detail in the next slides. Primary memory. It is also known as the main memory of the computer. Why? Because computers cannot run without it. Primary memory is directly connected to the master processor. So the CPU can directly access the data from the primary memory. Random accessing scheme is generally employed to primary memory. However, there are also other data accessing schemes that can be used, such as sequential access and direct access. The speed of the primary memory is more than the other type. The power consumption is also high and it is costly. The main reason behind this is that it employs random access scheme, which is generally faster of the data accessing schemes, and it requires quite complicated circuitry. which makes primary memory faster, more power consuming and expensive. It is electronic in nature and made up of semiconductors. And the most important point is that it is partially volatile. First of all, volatile means that as soon as power is turned off, the data and instructions stored in the memory would be lost. Most of the people say that it is volatile, but it is not completely volatile because primary memory consists of two types of memories, RAM memory and ROM memory, where RAM is completely volatile in nature, but ROM is non-volatile and it stores instructions which helps in loading the operating system from hard disk at the time of booting process. Now let's understand what is secondary memory. Secondary memory is also known as auxiliary memory because a computer could work without a secondary memory. Secondary memory is generally connected to the intermediary device and the master processor cannot directly access its data. So the data in the secondary memory can be accessed by CPU only if it is transferred to the primary memory first. The power consumption in secondary memory is less. These memories are available in low cost and works in slow manner. It can employ any of the accessing schemes such as sequential, direct and random access. This is the reason it is slow, less power consuming and cost effective. For constructing secondary memory, magnetic or optical material can be used. Magnetic storage like hard disk, optical media like CDs, DVDs and semiconductor flash memories are the examples of secondary storage. It is non-volatile memory as loss of power does not affect the storage of the data in the memories. Secondary memory usually comes in larger size such as in terabytes. Now let's understand the difference between primary memory and secondary memory with the help of the comparison chart. Primary memory is also known as main memory, secondary memory is also known as auxiliary memory. Primary memory is partially volatile in nature while secondary memory is non-volatile in nature. A CPU can directly access the primary memory while a CPU cannot directly access a secondary memory. Accessing the data from primary memory is faster while it is slow in secondary memory. Primary memory is constructed using semiconductors. On the other hand, secondary memory is constructed using magnetic and optical material. Primary memory is accessed by data bus. In contrast, secondary memory is accessed by input-output channels. The cost of the primary memory is high, whereas secondary memory is less expensive. A computer has a small primary memory. On the contrary, a computer has a larger secondary memory. The primary memory devices are usually affixed on motherboard inside the computer system. That is why it is internal. While the secondary memory devices may be present inside or outside the computer system, so it can be external. Power consumption in primary memory is more. On the other hand, it is less in secondary memory. Data and instructions to be currently executed are copied to main memory, whereas data to be permanently stored is kept in secondary memory. However, many IT professionals say that there are three types of memory: primary memory, secondary memory and cache memory. Cache is the fastest type of memory, but here we have only discussed the basic types. In the next video we will discuss what is the cache memory. So guys, this is all for today. Thanks for watching. I hope you would like this video. If you like it, please guys like the video, share the video and subscribe our channel. And I will see you in the next one.
Central Processing Unit. CPU carries out the instructions of the program. It contains circuits that control the operations of the hardware and the circuitry that performs arithmetic and logical operation. Data is transferred from primary storage to the CPU with the results sent back to the primary storage. The question is, how does a CPU work? Let's see.
Hi there, I'm Gary Sims and this is Gary Explains. Now we talk a lot about, the CPU or the processor that's in our desktop or our laptop or in our smartphone, and actually it raises the question, how do CPUs work? What is a CPU? What are the basic building blocks of a CPU? Well, if you want to find out, please let me explain. Okay, so CPU stands for Central Processing Unit, CPU. And it's basically the fundamental building block of a computer. Now, way back when the computers were first, electronic computers were first being invented, what happened is that computers had a fixed purpose. So there was a set of electronic circuits that allowed you to do one particular thing. And a very famous example is a computer that used to track torpedoes in submarines. Now that's the only thing it could do, and the circuits were designed in such a way that when you press the right buttons, it would do the relevant calculations and the relevant output will be displayed. Now, after that, of course, came the idea of a stored program computer, and that's what we use today. We have computers that run programs that are stored in memory. So what does that mean? Well, the basic model is this. You have two components. You have the CPU and you have memory. This is a very simplified example, but you have the CPU and you have memory. And the CPU fetches an instruction, what it needs to do next from the memory. It then executes that instruction. It then goes back and fetches the next instruction from memory, and then it then executes that instruction, and so on. Now, of course, today there are loads of other things that happen. You've got graphics cards, and you've got the PCI bus, and you've got USB, and you've got hard disk. But at the very simplest level, the memory and the CPU work together to feed the CPU with a set of instructions. So what do these instructions tell the CPU to do? Well, the CPU has a state, and that state is measured in two different ways. One is by a set of registers, and one is by some status flags. Now, the registers are little slots, little holes where you can put bits of information and you can manipulate those bits of information. So, for example, a instruction might be load from another part of memory this value into register number 1. So the computer would fetch the instruction from the memory, it would work out what it needs to do, and to do that it would then fetch the other bit of memory, the number that we want to load, and it would put that then into register number 1. And it then would go on to do the next instruction. Now, this is where we come to the status part, because there's a part of the CPU state which is where its program counter is. Where in memory is it fetching the next instruction? So every time you execute an instruction, the program counter is incremented. It goes forward to the next location in memory. So in our example, having fetched the data from an address in memory, the next instruction might say, fetch another piece of data from a different place in memory and put that into register number 2. And again, at this point, the CPU would fetch that from the memory, it would put it in register number 2, it would increment the program counter, and then it would go and get the next instruction to execute. And now this third instruction might be, for example, add the contents of register number 1 and the contents of register number 2 and put the result in register number 3. Now in this case, it doesn't need to go out to memory now to fetch any more data. It can do all of this internally. So it'll do the add and it will change register number 3 to be the result of that add. Then the CPU will go and get the next instruction and see what it has to do next. Now there's lots of optimization that goes on during this fetch decode process. For example, I have a video here on instructions per cycle, which should give you some more insight into the kinds of optimizations that can happen. But at our very basic level, this is what happens. An instruction is fetched from memory, then the status of the CPU is updated, either the registers and or the status flags. Now, for example, having added those numbers together, other instructions can happen, like, well, let's compare the result. Was the result greater than 100? Is the result 0? And then because of that comparison, the program counter can then either remain as it is and the program just carries on going, or the program can branch. It can jump to another part of memory to do something else. So think about a computer game. You've got a little sprite bouncing on the screen, and when the sprite gets to the left-hand side, which is normally 0, the 0 axis, then you can say, oh, the character died, or he has to bounce, or whatever. And so at that point you say, compare the position of the sprite with 0. Is it 0? Yes, okay. Jump to another part of the program to handle what happens when the character gets to 0. So jumping, it actually happens all the time in computer programs. You compare conditions. If something has happened, you jump somewhere else. If something hasn't happened, you carry on going and doing what you're doing. Of course, also you jump a lot when you're looping. So when the program gets to the bottom of all the steps it wants to do, it can jump right back up to the top again and start executing them again. And there are a whole bunch of other instructions. And one of the important instructions is also to write back something to the memory. So up until now, we've loaded things from the memory, we've multiplied them, we've compared them, but now also you can take that result and you can write it back to the memory. So the computer would read the next instruction from the program counter, it would decode it, work out what it is, it would say, I now need to write the value of register number 3 to this place in memory. So now it would go about writing the result back to a different place in memory. And of course, later in the program, you might fetch that back in again and then compare it and do more calculations on it. And that's how a computer program works. Now, of course, again, there are lots of optimizations that can happen, because if you know you're going to use that value later, it would be much better to keep it in a register. But of course, there are a limited number of registers. You might have, 4 gigabytes or 8 gigabytes of RAM, but registers you've got like maybe 16 or 32, depending on the CPU and the system architecture. So there's a very limited amount of space of where you can read and write these little bits of numbers. So at some point you have to write them back out to main memory, because there just isn't space inside of the CPU. And basically that's it. Now, of course, today we have lots of different CPU architectures. The instructions, exactly how they're formed for loading and storing, comparing, is different across each CPU, but basically they're the same. So of course today we have Intel x86 processors that are also AMD processors that are largely compatible with the Intel ones. Then of course you've got ARM processors that we find maybe in our smartphones and in Chromebooks. And then there are other processors that you might find in mainframes, for example, the Power series from IBM, and there's several others. But basically all these CPUs do exactly the same thing. They fetch an instruction from memory, they decode it, they execute it, they update their status, and then if required, they write something back out to memory again. Now in the next video, I'd like to show you some actual assembly language that's the human form of these instructions, so we can get an idea of how the CPU is told to load and to store and to manipulate data and registers inside of its internal state. So that's what we're going to do in the next video, when we can look at how CPUs work. Well, my name is Gary Sims and this is Gary Explains. I really do hope you enjoyed this video. Please hit that bell notification icon so you become part of our notification squad. Please comment below, tell me what you think about this video. Please share on social media. And well, that's about it. I'll see you in the next one.